And I will share my screen. Zoom in. Let me just double check quickly that I actually are recording. Yeah, yes, it's recording. So you've seen this list before. So far we've gone through the points 1 to 7, and these are been captured and saved as video files and put up on my YouTube channel as 6 separate videos. So hopefully you will be finding it's convenient actually to have this accessible this way, so to review for later on when you need it. But today's topic is the last one then in the series for now. And as I said several times already, this topic around business logic heavily relies on the previous topics, data models for tables. Basically, understanding the topic of data models for tables allows you to create business logic, implement an algorithm that actually pulls data that needs to be processed and then puts data out again when the calculation is finished and you need to pass on your changes or results. Everything is done through the data models for tables. The field model is used by the business logic to link different algorithms together in a certain order, or I would say in the correct order. So, but I'll come back to this, but from the data tables model, you get data, and from the fields models, you get a better understanding of in what order the logic elements should execute, basically. So let's go straight into the topic. You will find that I added recently a new seminar file called 8 Data Models for Logic. Let me go to the top on this file. I had some goals when I created the business logic model. We didn't previously have such a model formula declared in Andrega. Instead, we were kind of using our own thinking about it everywhere we wanted to implement some logic. And that was kind of lucky cases. Most time you would see that the business layer was actually directly in the code behind. If you recall, even one of the first topics I had is how we could separate data and business models or layers from UI code. And unfortunately, prior to this implementation that you see here, many locations for business logic was linked to code behind. And in some cases, actually, it was linked to the setter and getter functionality in the data model itself, which is a kind of an even worse practice, I think. As I said in the clean coding session, you would want to make sure that when you implement a setter and getter functionality, it should have little, if no, side effects. So if you look to the WinForms implementation, where we trigger calculations due to user input, many of the logic elements that are triggered is actually triggered as part of the setter functionality, which is kind of, yeah, it's not a good idea. So to avoid that, I created this business logic model. And this is a very important step, to keep the logic away from the data model and field model. It doesn't prevent the data logic model to use the data model and field model. That, on the contrary, it heavily relies on this. But the data model and the field model itself should know nothing about logic. These should be pure models. I wanted also to make sure that when I created this business logic framework, it should be capable of handling almost any types of business logic. And what I had in mind when I started this work and started creating the framework, and when I ended up creating namings for different elements, was that I'm responsible currently in the team to create the build pipeline. So basically, when Elena creates an installer, she executes a build pipeline on the Jenkins site that I configured, or actually now I would say Andreas has taken this over, so now it's Andreas's responsibility. But basically, he has configured the build pipes according to the initial specification I created. And if you think about what it goes into actually creating an installer, there's a lot of different logic steps, you can say. One would be to compile the code, and you have different compilations. You have different, you compile C# and you compile TypeScript, and then you have the packaging of the code, and then finally you create an executable, which is the installer itself. And there's a lot of different elements in this as well. So I had this idea that why not create my business logic module around build pipes, because in this kind of Jenkins setting, it's very generalized and can do a lot of different things. So the build pipe was the naming I chose for this top level. So the top level, if the API is named as build pipes. Now, I also wanted to make sure that if you wanted to recreate or port existing business logic, you had the opportunity to actually split out individual components. Often these previous implementations were doing a lot of stuff. Again, if you think about the clean coding principles, a function should do only one thing well, right? And having the ability to do the same for business logic is very important, I think. So it should be possible to easily separate out individual elements of a business logic or complex logic, and then you have the privilege actually to split it out, and you using the build pipe and certain attributes of the build pipe, you know that these elements will actually be executed in the correct order. So you don't actually need to create your own collection of logic elements to ensure that they are executed in the correct order. You can leave that responsibility to the build pipe. In fact, when you do that, and you hand that over to the build pipe, you also gain a number of benefits in that the build pipe has some intelligence in optimizing the build pipe, in having all the elements in the build pipe which are actually needed based on the current input. Another benefit with the data model that I implemented, or the logic model that I implemented, is that it gives you the ability to keep track of individual data changes. And this is very important to be able to have a good optimization around this, transferring data from server to the client when you have done calculations on the server. But also it's important when you want to save changes to the database, that you don't need to save everything, because now you have a good understanding of what has changed. So you need only to save the changed data to the database. So it's a huge optimization that you can do that when you may have this detailed information of what has changed. This also easily facilitates adding functionality to undo redo. Currently, I haven't made that available for the user, but just know that the framework that I created for business logic allows a very easy implementation for almost any level of undo redo. I say almost any level because I have a limit to the current tracking to only track the last 10 changes, but that's easily configured. Currently, then, we have a limited set of build pipes created. And you would see that I created a build pipe for project level calculations. Then we have a dedicated build pipe for activity rows. And then also we have a build pipe for what I will call a generalized view build pipe. Now the project build pipe makes use of both the activity build pipe and the view build pipe, but they can also be used individually. So if you have an activity you want to make sure that it's up to date based on the underlying business rules, then you can actually call on this directly if you like. And also, so far, the project build pipe is the only use case for the view build pipe. This ensures that the project is grouped, sorted, and filtered. It also handles the roll-up calculations that are needed when we want to pass data from the server to the client. Because of course, if the client has applied a view, then of course the calculations need to honor that view setting, and that is basically done by making sure that the build pipe is running. The project build pipe is running the view build pipe as part of its processing. So let's take a look at some code. I'm going to switch over to this mode because it's a bit easier. So let's look at what is a project build pipe. And let's go to the top so you see what this looks like. So a project build pipe is basically derived from the generalized build pipe. The input for this generalization is an enum. As I said, a build pipe consists of individual steps, and for the project level, these are the steps we currently have defined. So we have a field calculation step. We calculate the critical path. Then we do the non-summary calculations. Then we apply the currently selected view. We do the summary calculations, and then lastly we do some resource calculations. Just know that you can extend on this enum list by adding new elements to the bottom, and you don't need to concern yourself that the order it should be correct. This ordering is actually part of the definition you would see down here. So you see here, you can actually enforce an ordering of these steps that are different from the enum order. Just want to highlight that the order in the enum is not the same thing as the expected ordering of steps. That's down here. So that's build pipe and relationship to build step enum. You would also see that the build pipe is acting on a project dynamic contract. So that's basically the main input for the build pipe. When you execute the build pipe, you create the build pipe, and then you apply the build action on a project dynamic contract. Some cases, you also want to add some extra information to be available for the business implementation. So some logic might not have the values, you would need the values that are not stored directly on the project dynamic contract, which is the input object. In which case, what you would want to do is to create a build context and add it to the build pipe, which with data that is not actually part of the project dynamic contract itself. But I'll come back to this, but that's kind of the three inputs. You have an enum detailing the steps. You have the type that is the main type for the build, and then you have context information that also is accessible for the individual build steps. I think that's sufficient for an overview. If you look to the activity build pipe, it has the same layout. It has a number of steps. You do field calculations, and then assignment calculations. You do the assignment rollup, and then you have row calculations. You would notice that I wanted to highlight this because it's kind of an important fact. You would see that the project build pipe accepts the project dynamic contract, whereas the activity build pipe doesn't accept. Well, it accepts an activity dynamic contract, but it doesn't declare it necessarily to be an activity dynamic contract. If you remember the previous session when I talked about the field model, there's a way to construct a relationship between different data contracts. So having it generalized like this allows the activity build pipe to work on activity level, but at the same time it will also work on the project level, because it doesn't make any assumptions at this declaration level that it should be an activity. It could even be a project. And this is kind of the flexibility I wanted to make sure that I implemented in the framework, because one of the things we had problem with in the desktop client is that we added the ability for the user to add activity columns to the project list. So basically, the list is of projects, but there's a one-to-one relationship between a project and the activity route for this project. So basically, a given project would have one activity route, right? Route activity, I would say. But the problem was that to display the route activity data in the project table, sometimes these data needs to be calculated as it would be calculated in an ordinary activity table. And previously, the way we did this was to implement the business implementation twice. So basically, we had a business implementation that took care of the calculations for activity level entities, and then we have the same calculations with a new implementations for the project level in case where the activity was a root activity. But that's not no longer needed, actually. You can actually apply the activity build pipe to the project, and it will actually make sure that the project's root activity calculations are carried out. So that's kind of very important to know. So that's why it's entity dynamic wrapper, which is a generalized class, and not specifically to a project entity or an activity entity. We have the view build pipe. Again, you would see that this is generalized, such a way that it's working not on a specific data contract. It's actually working on any types of projects, class. It could be a collection, it could be an array, but the collection, an array, or otherwise the class that you give it as input needs to have entity dynamic children. So again, I think now I might be losing you guys because this is so abstract that it's very hard to understand the concept of all these options in declaration. So I will show you later on unit test I created that illustrates the use of this construct. So hopefully the unit test that I will show you a bit later on in the seminar will let you know how to interpret all of these different options. So, but yeah, I think looking at my code, this is probably one of the more advanced constructs, and the search will take you some time to get to know well and know how to use properly. But hopefully you will find a lot of samples on how it's being used today, and from that you can start learning how to use it yourself. But basically, the view build pipe consists of these 4 steps. It is a filter step, roll-up step, and group step, and the filter, sort, group, and roll-up. And the ordering of these steps are not accidental. It's very important that these are done in the correct order, because if you look to the implementation of the roll-up functionality, it actually makes use of the fact that it's already been filtered, sorted, and grouped. So it's basically applying a one pass scan to do the calculations. So it knows that it can actually start doing calculations from the bottom of the table and towards the top, and it wouldn't be having to go up and down, up and down. So this makes sure that roll-up implementation is very efficient in that it only needs to scan the table in one direction from bottom to top. I thought to show a bit more on this implementation as examples, but I think it might be a bit too advanced, to be honest, given also the shortness of time. So I think I will defer for you to do that yourself. You will see that I put, when describing the build steps, some links to these individual steps. I do encourage you, if you wanted to create your own build step, to take a look at them, because they're quite useful to get an understanding of how to implement a step. But maybe for now I shall defer for you to do that later. Another important aspect to keep in mind is that often you would see that when creating a build pipe, the constructor is private, and this will be able to make use of the async operator in constructing the build pipe. So for now, just know that you don't actually declare the build pipe by calling on the constructor. You would actually just call on this static function called create to create the build pipe. I also mentioned that together with the input you have for the build is the object you want to act on, but also sometimes the object doesn't contain all the data needed by the business implementation, the logic implementation. In which case, there's one way to pass it to the logic, and that is through the build context. So let's take a look at what kind of build context there exists today. So here you can see on the right side the class relationships between the base class of build context. And so on top you would see the build context. Beneath there is a calendar build context. Basically this adds some reference to the work calendar and hours per day, and also has some visibility functions to some calculations. Then we have the view build context, and of course this then contains the view definition itself. There's also some access functions to get hold of all the rows in the table, and also when you've done your view changes past the tables, the row is set back to the data sets. And then we have the activity build context, and project build context, and assignment build context. So basically for all the main entities that we have defined build pipes for. Actually, this is not actually used currently. I did create an assignment build pipe. You will see that in the code, but it's so far not used. But maybe later on we will be adding functionality to it. So don't be too confused about that. Assignment build context is currently there, but it's not actually used. It's only the project build context and activity build context and the view build context itself, which can be constructed as a separate context, which is currently in use. But you can see here, if I go to the activity build context, you would have, for instance, things like calculated fixed cost method available to be tested and checked for. So some logic, activity level logic, would need access to this setting to be able to do its action properly. Also, you would see any activity calculation also have access to the entire project. We found that it's also to be needed based on the current implementation. So it's possible for the activity to query basically any and all project level properties. And not only this fixed cost method, by the way. This is just an extraction of everything that is inside the project. Okay, back to the overview. So just to summarize then, the top-down breakdown from the logic model is that it consists of build pipes, which is consisting of individual build steps. And you've seen how the build steps are looking, how they're declared. You got to now understand the concept of the build context. And then I want to introduce the concept of dependencies. So often when you implement a functionality, and break it down into small components, you still want to make sure that the components are executed in the correct order. And the way to ensure that is that you set up dependencies. So basically, a step could declare its dependencies on other steps. And the way it's handled in the API is that if you look to the critical path step, you declare here a list of dependencies. So basically, this has two or several important functions. When you add the dependency like this, it ensures that, one, that the data is read from the database if it's stored in a database. Two, if it's a calculated field, you know that the calculation of this field will be triggered before your own calculation. So these are very important facts to know. So declaring it here ensures that it's loaded from database, and it will also be calculated before this calculation is carried out. So when critical path calculation is triggered, constraint dates will be read from database, and there's some calculations actually being linked to current start. Sometimes current start will be needed to be updated based on other constraints, other input, and this makes sure that the current start calculations is done before the critical path step is done. So this is the way we are declaring our dependencies, and you will see that the dependency is linked against the field model. So as we saw when declaring the field model, we declare these interface classes. So we're using name of as a convention here, and then we don't explicitly say it to be an activity entity, because as I said, this should also happily work for project entities. So the input here is actually a variable, not fixed. But again, just to summarize, we have our build pipe, which consists of steps, and each step is allowed to declare its dependencies on other steps. And the dependencies are done through the field model. So if I go to the class itself, you will see that the field dependency has a root entity. And there's a convenience function that converts this string to an enum. So basically, you would see that there's an entity for activity, entity for project, etc., etc. You already shouldn't be familiar with this. Also, there's a reference to the static name. So root entity, static name, and entity, these should be familiar with you for you when you have studied and understood the field model. So yeah, the dependencies are declared through the field model properties. There's another functionality linked to the build context, and that is the build context contains the setter and getter functionality you want to apply. If you have your business logic calculate and data and pass it back to the data model using the access functions or access functions that is part of the data model, then you wouldn't be able to get much of the benefits of using the build pipe. So instead of actually calling on the data model's own setter and getter, you want to make sure that you use the build context setter and getter. I will show you this. Just before I do that, using these getter setters, what you do is that you get a complete coverage of the value change history. And as I said previously, knowing what the value has changed allows you to optimize the amount of data you've transferred back to the client and what you save into the database. So let's take a look at what I mean by getter and setter. So this business logic is to calculate the remaining value based on the current value and the action value. And you can see here, when it's done these calculations, it's not, let me change the code a bit. It could be wrapper So it could have been like this. I think this is static name. But and it would be working to pass data back into the data model, but you would not be updating the change history. And that way, when you are expecting it to be passed back to the web client after being calculated, it would not be part of that data transfer because it's not flagged as a changed value. So using the context set value functionality, make sure that it's flagged to be transferred and to be saved. So it's very important to realize this. There's also one thing which is part of the context information, and that is kind of an advanced side effect of the current activity business layer. I don't know if you know this before, but we do calculations differently depending on where the user puts new data into the spreadsheet or the table. So basically, if the user changes the current value, then remaining should be calculated in a certain way. But if the change has come because the user has changed the actual value, the calculation should be done in a different way. So I can't just say that I always want to calculate the remaining value. I actually need to know what's the source of the latest change. So this build context allows me to keep track of that and ask for that. You can see here, I can actually check as part of the calculations if the actual data has changed and or if the current has changed. It could be that both has changed in the certain conditions. We allow that, but sometimes, most often, it would be only one that has changed, and then you do your check and you do your calculations based on that. So while I have the code open, there's something I would like to highlight as well, and that is the runtime data flow around a business step. I'm thinking that it's more than likely that you'll be creating your own individual business steps eventually. I don't think it will be necessary for you to create your own build pipes, to be honest. I don't see the need for many more build pipes than we currently have in our toolkit. But certainly you might be finding yourself working on adding support for new build steps. So just know that the constructor is invoked first, and as such, it should only handle data, or it should only be containing its own business logic, which is independent of later input. So then, because the data that is actually it will be used for is not known at the moment. So what I'm saying is that you construct the business step before it knows everything about what it should do. Now, the second part of the runtime is that you get a call to get result. This is also before the data is actually passed to be calculated. So again, you can't ask for specifics on the input data here. It's only when you come into this scope that you actually have data to query. So in this setting here, you know that all the values that are in previous dependencies have been calculated, etc., etc. So just know there's three particular times that where you act on. You have the constructor, then you have the call to create the step. It's the calculation. And it's actually triggering the calculation as a third element. You can see here, and this might look strange, but it's returning a function rather than actually triggering the calculation directly. And this is very important. This is a way to make sure that everything is done in the proper order. So it's again, it's returning a function and not directly triggering the calculation. The triggering actually, it's outside and part of the execution of the build pipe. Hopefully that's understood. So let me see the time. I haven't spent too much time yet, but this is a very advanced topic because there's quite a high amount of abstraction to it. So I think it would be good actually to show you some unit tests where this is actually used directly. Maybe this will make a bit more sense to what you've seen. So this is a unit test where I want to make sure that I calculate the remaining work. And if you look to the input here, you would see currently current work is set to be 10 and actual work set to be 2. And I'm intentionally setting this to be an invalid value. So remaining work I set to be 0. And this doesn't make sense actually. It's not a valid configuration to be stored in the database. So what I wanted to make sure is that remaining work is calculated based on these two values. And if you know Adrega, it would be the current work minus actual work is remaining work. So let's see how I can trigger these calculations to be done. So basically what I do first is I create an activity with the input values. Then I create a context. As I said, you pass extra informations to the logic using the context. In fact, context needs always to be created, otherwise you will get a crash. So you can't currently pass a null value to this property parameter. Then this is the way to construct the build pipe. You would see that I create a dedicated service, and part of the service actually is to return build pipes. Build pipes needs only be constructed once in the entire lifetime of the application because they're invariant. So basically there's some minor saving in that you reuse the build pipes this way. Having created the activity, the context, the build pipe, now it's time to call on the build pipe itself. And you can see here, as I said, the input for the build is the object it's working on. It's working on an activity level entity and the context. And then I validate the remaining work to be changed from my input of 0 values to 8. So let's take a look at how it looks when I run it. I have filtered it out, sorry, let me find it. So you can see here, I have actually written some output lines as well. It's here to illustrate that what you can do to debug basically. So these are usability functions not used by the end user code, but actually it's very convenient for you as a developer to have access to. So basically, this is a function that exists on the data contract level and also directly down to the lowest level, well, not on the dictionary itself, but on the row level. So if you wanted to ask under the debugging session, or if you wanted to print out like I do here, the actual content of the dictionary, then you can do it this way. You can see here, in this case, after constructing the activity, this is the content of the dictionary. You have the CRUD state, which is currently the crate. You have the actual work. So this is the input, and as a 2, you have an automated generated task UID of 1. You have the task work and task name. You can see the task name is set, right? Sorry, the task UID is not generated, actually, it's input here. So again, I have a similar output after running the build pipe, and you can see that everything is the same, apart from remaining work is changed from 0 to 8. But yeah, having implemented this dictionary to JSON function, I wanted to highlight it because it might be very useful for you to know. I use this quite a lot when trying to understand what happens during debugging sessions. Now, I talked about some flexibility around the activity level calculation. So you would see that, again, I'm getting hold of the activity build pipe, but this time you would see that I'm not applying it to activity entity. I'm actually applying it to a project entity. And this should be familiar with you from my last session. This is creating a dictionary specifically for the project contract. Then I populate this dictionary with activity entity data with using this entity project input. Now just know that the dictionary is actually a dictionary created to be also shorted with a project contract. But here it's actually possible to use the activity build pipe on the project dictionary. And this is important in that when I created the build pipe, I didn't specify it to be activity contract. I said it could be a generalized contract. In fact, it could be a project contract or it could be an activity contract. And I think the best way to show this is actually what happens on the dictionary level. So let me run this. And let's see, basically it's the same thing we did before. I create an activity root activity here, but rather than actually it's being its own entity, it's actually directly associated with a project, right? And you can see here, the dictionary entry for the task name is not task name, it's prefixed with R underscore. I talked about this, that the row name are generated from the paths. And yeah, if this is getting to be confusing, if you don't understand why it's now called R underscore task name, then you will want to look back to the previous session where I talked about how to link different data contracts through the field model like this. But basically, this is a huge achievement in that we no longer need to duplicate the business logic that we need to maintain the consistency of activity data when presenting the activity data in the project list. It used to be that we had a very limited support for what project table could show as activity data, because there were so many calculations being done on activity level, which we didn't actually have time or resources or inclination to reproduce to be presented into the project list. So basically, we limited very greatly the amount of activity data we can add to the project list. But there's with this flexible framework, you no longer need to limit the amount of activity level data you add into the project list. Any activity data that you see in the activity table could be added to the project table, and it could be available, it will be displayed with the correctly calculated values. I have another example I wanted to go through, and that's the roll-up step. And I talked about the view build pipe being quite advanced in that it's quite generalized. I wanted to show you how you can apply the view build pipe outside of its current use case. As I said, currently, if you look to the implementation, it's currently only used by the project build pipe to make sure that everything is set up correctly before you do your calculations. But you can actually apply it outside of the build contract as well, the project build pipe. And I think this is something I would like to look closer at implementing in 5.6 or later versions of Adrega, because one of the things we don't have today, let me open and show you. So if I group this by calendar, for instance, then you can see here, this grouping row only says that it's grouped by calendar, right? But the way we often use it when grouping is as a summary. So if I open, okay, this is the 5.4. Let me open the Gantt report and see it here. You see this top level is also a grouping level, and it's actually showing aggregated values on this row. It's a summary row, right? It's an aggregation row, and it is not possible to do that currently with Telerik. It has no support for it. So I'm thinking that in the near future, we want to make sure that we can also do this for non-activity tables. So we want to do it in the project table. We want to do it in the user table, perhaps. And as such, we can actually already say that we have implemented the back-end support for this. And you can see here, I'm actually now simulating how that functionality would be used by this page. So basically, you would see that I create 3 users. They share, 2 of them share a similar code. They all have different rates. Here I create a view where I say that I'm grouping the view by user code. I have some boilerplate here to construct context, build context for the view pipe. And then I join up the 3 different users in a single collection. And then I create or get access to the build pipe, the view build pipe. And then on this line, you will see that I'm actually invoking on the build pipe. So again, the steps was to create 3 users, create the view specifying the grouping. I create a context. Now I join the 3 users under one collection, and then I invoke on the build pipe. Having done that, it's now possible actually to look at generated data, and let's actually run this and see if I actually create a visualization of this. You can see here that, as you would expect, actually, I created some grouping rows. So as you saw, I am grouping by code. So you can see the first group row has a code of 1. And you can see here the children, which all share code 1, has a user rate of 5 and 12, which sums up to 17. And then there's a single entity row, which has its own unique code, which is code 2. And so it has a summary of to be 10. So basically, this functionality is actually required as part of the Angular Gantt calculations. But I created a solution for it, its own dedicated build pipe, to be able to reuse the same logic for grouping, sorting, filtering, and rollup to any of our other tables as well. So basically, this is now ready to be applied as part of this grouping functionality you would see here in this table. So there's a little bit extra work now to actually enable this functionality for all tables in Adrega. But again, that's not currently in the scope of 5.5, but certainly I think we would talk about it to be implemented quickly in 5.6. So let's go back to the main. So I think actually this is a complete rundown of everything I wanted to talk about. Hopefully, you weren't too confused about this. I think, as I said, this is probably the most advanced topic so far in our internal API. It heavily relies on understanding the data model, and also heavily relies on understanding the field model. So if you are a bit uncertain about the data model and field model, I do suggest you spend some time reviewing those seminar videos, and then come back to this, because this might be confusing you if you don't know fairly well the previous talks. In particular, if you struggle to understand all the nuances of what I'm doing here, and what is actually stored in the dictionary as far as key values, then I suggest you review the field model seminar. But again, without actually having such a way to link entities, we would have to create a dedicated logic to calculate activity level fields and then root activity fields for the project entity. So hopefully you appreciate this flexibility and how it saves lots of extra implementation and code. Yeah, are there any questions or comments to today's topic? It's very quiet. Did I lose someone? Is everyone here?
No, we are here.
Good.
I was muted as usual. I don't have any particular comments, at least.
So let me set this in the framework of your current assignments. Then, Olga, you want to create a solution for timesheet import, right?
Yeah.
So what I think is the most important entry point for you is actually not discussed as a topic in our seminars so far, but it's actually how to access project data on the server side. And one thing I wanted to show you is that we have a function to actually dedicated worker class for loading project data. And this maintains this implementation is class. It maintains and updates the project data cache. So I think if you wanted to not when you finish understanding how timesheet import works in dashboard, sorry, in the desktop client, your next step to study, I think, is this project loader and how it's used today.
Okay.
Project loader worker. All project data will load it into this class.
Yes, in fact, when you open, let me actually open the develop branch. Let me explain how data is stored in the, or how it's introduced into the cache. When I open the project page now, there's a request to get project data. I think it would be towards the bottom here. So you see get projects.
Mm-hmm.
So once this is called and once it has been processed and turns data, all projects is found in the cache, but not necessarily all activity data. When you request this this data to be put into this table, let me just did that. I'm not sure why it's hanging now. Okay, there you go. I need to correct myself actually, because now I didn't open the project list. I opened tracking. So when I open the tracking now, it's not only loading the project data and the project root activity data, it's actually loading everything. So you would see here that there's a second call for get projects, which is specifically to load this one project and all its associated activity, fixed costs, resources, things like that. So it might be the case that the project cache is empty. In this case, you need to load and make sure that you trigger the correct loading of the project. Also, when you trigger the loading of the project, you, as part of the trigger, you specify what other tables you should also load. So, for instance, a project could be loading the project table and the activity table only. It could be loading the project table, activity links, fixed cost register, basically. So that's part of. Let me just, because you talk about it. So this is the request, right, to load a project, and the project has the request has a scope, and the scope is basically an array of entities. So this is very linked to the field model, as you know, we have different entities declared in the field model. So one is for the activity and one is for links and things like that. So you would see that when we create requests to load data, we also often specified the scope to be loaded. So you can see this is a function on the server side. Sorry, it's a test, but you can see here, in this case, I want to load the data with activity data, link data, assignment data, resource data, and resource data. So, so back to your assignment, Olga, you want to study basically how load project worker works and how it's currently used. And that way you know how to make sure that the data that you get from the timesheets should be stored in association with the project cache.
Okay, hope we'll understand this.
Bernd, could you clarify? At current moment, logic is the following. At first, we load all projects. After that, we process data from timesheets, update data in project model according to timesheet data, and after that, we resave full project. In new model, we may load activity data, resource data, assignment data, update cache project, and after that, model will understand what data should be saved, or logic should be right for it.
No, we want to make sure that Olga, when you implement it, that you use the concept of the build step and your build step to introduce data to the server cache should make sure that it uses the build steps context such a way that the cache project knows that you have changed the individual values. And so what you basically have is that recently I added a generation tracker to the project dynamic contracts. So basically, your implementation should make sure that it adds new entries to this dictionary. But let's circle back to that. I think that's much too more detailed now. But for now, study the current implementation for desktop, right? Then study the utility class to load data. And then once you have done that, let's sit down together and I'm going to talk about how to make sure that when you make changes to this cached project data, it's actually flagged to be saved correctly.
Mm-hmm.
Okay, like a good plan.
Good. For your own assignment, Alexei, if I open your next 5.5 assignment, I think this is a client-side only assignment. You might want to correct me if I'm wrong, Andreas, but my thinking would be that Alexei's next assignment would be activity details, maybe even select calendar. Both of these, I think, can be solved on the client side only. Maybe start with calendar, actually. Because basically, the calendar selection functionality is basically to have a possibility to select the calendar name and get a pick list. And there are several implementations of such functionality already on the client side, which can be reused. But again, as I invite Olga to talk with me, Alexei, for her 5.5 assignment, I do suggest that you also start by maybe giving me a call, and we can I can show you some code that will be relevant for your for this assignment. Okay. Good. Are there anything else we need to touch on, either in relationship to my talk today or to your upcoming assignments? No, in that case, I will end it here today and wish everyone a good day, and let's meet again and talk tomorrow. So see you then.
Bye-bye.
Okay.
Thank you.
Thank you.
Bernd.
Bye-bye.
Bye-bye.
Have a nice day. Bye bye.